Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Aiman Shamlan bin Anwar. So today I will present my final year project, which is differences between cascade structure and single loop speed control design for DC motor. So for the past semester, I have designed my speed control design for DC motor using cascade structure. So this semester we mainly focus on single loop speed control design. So now let's explain the comparison between cascade structure and single loop speed control design. So for cascade structure, we have both speed and torque loop. So we have to design the PI controller for torque loop, and also have to design to the PI controller for the speed loop. However, for the single loop speed control design, we only use the single loop, which is the speed loop. So we'll be implementing PI controller and also lead compensator to the system. So here we have the open loop plot for both systems. So the upper one is for cascade structure, the both upper one for cascade structure, and the bottom one for the single loop speed control design. If we compare the phase margin obtained, we obtain that phase margin at cascade structure is higher than the phase margin at the single loop speed control design. However, the gain the crossover frequency or the closed loop bandwidth we obtain from cascade structure is much lower. This is because the speed loop for cascade structure is dependent to the torque loop. The rule is the crossover frequency or the closed loop bandwidth for speed loop must be 10 decades lower than the crossover frequency that we got from the torque loop. So that was the main difference. Then we go to the last linear simulation. In the last linear simulation, the main difference we can see here is how we set the limit for the maximum allowable torque for our system. So for cascade structure, we're using saturation, which we set the upper limit and lower limit of the saturation value. However, for the single loop speed control design, we'll be designing the current limiter circuit with the reference value here that we set, which is exactly the same as the cascade structure. In the single loop speed control design, we also have to do the PID wind up setting, as we shown here. We have to do some wind up setting to smoothing the overshoot occur in the system response. So let's go to the system output response. So here we have the output response of the system. So we have three waveforms. The upper one is PWM, and the second one we have the torque generated, and the last one we have the speed output response. If we compare the torque produced, we can see ripple occur at single loop speed control design. This is due to the current limiter circuit relay setting that we changed to be plus minus 0.1. Now let me go to the speed response. As we can see here, it's quite the same, but it's not exactly the same because of the difference between the closed loop bandwidth and the gain crossover frequency that we got from the small signal analysis. And also, if we reverse back, if we doesn't do the PI wind up setting, we can see overshoot occur in the system. So I think that's all the difference that I can spot here. Thank you for watching, and Assalamualaikum warahmatullahi wabarakatuh.